What I want to cover just briefly is the theory of why this technique works, because it may bother some of you that we write out expressions like this, like x equals sine theta, when the problem doesn't say anything about x being equal to sine theta. So you might be wondering why I can do this. So I just want to relate this to the u substitution that you already know by asking you to look at this question. If you recall how we did this question, what we would do for a question like this is we would say u equals 2x plus 7, du is equal to 2 dx, and therefore dx is equal to 1 half du. So what you may recall is that we were able to replace this with the square root of u and this with 1 half du, but we still needed to find some way to clear that. So what we did is we solved for x in terms of u and wrote u minus 7 is equal to 2x, and therefore that x is equal to u minus 7 over 2. So this presumably didn't bother anybody after you learned how to do this. But there's no reason I couldn't have just started with x equals u minus 7 over 2. So if I had started the problem this way, if instead I had just written I just guessed really, really well and said, you know what, I think that I want to let x equal u minus 7 over 2. And then I'd said, oh, but wait a minute, what am I going to do with this 2x plus 7 here? I better solve for 2x, I better get an expression that involves 2x plus 7. I would say, oh, well, let me multiply both sides of the equation by 2, giving me 2x equals u minus 7, and now let me add 7 to both sides, giving me 2x plus 7 equals u. And then I would have had the same substitution. So there's no reason I have to start with one or the other. So if I'm given a problem that looks like this, and I say that, for some reason, I think that the substitution, I think that maybe the substitution, uh, u is equal to arc sine of x is going to somehow help me solve the problem. There's no reason I can't just start it this way by saying instead x is equal to the sine of u. And while I'm at it, why don't I just use the traditional variable that we use for trig functions and instead say x equals sine theta? Because of course math works. It really doesn't care whether we do the math in the Latin alphabet or the Greek alphabet, because ancient Rome and ancient Greece were really just a mere 100 miles apart anyway. So that's why this works. So that's the theory behind this. It's really not that different from u substitution. It's really just a question of how we're choosing the substituting variable and how we're expressing it.